Welcome to Midnight Physicist. You are lying back, eyes closed, as the universe stretches infinitely in all directions, an ocean of stars and galaxies. A soft hum of cosmic energy pulses around you, but there is a quiet emptiness that blankets it all. The vastness is almost overwhelming, yet comforting in its silence. You are not alone, though. Somewhere out there, in the farthest reaches of space, an unseen force exists, a whisper in the void guiding and shaping the cosmos. It's difficult to imagine, isn't it? The universe is so vast, so filled with light, yet much of it remains hidden from our eyes. A great mystery lurks just beyond our perception, a presence we cannot see, but we feel its effects everywhere. This invisible force is known as dark matter, and it has been with us since the beginning of time, quietly shaping everything we know. You can almost think of dark matter as the universe's invisible hand, gently guiding galaxies and stars, the cosmic dance of gravity. Yet, despite its significance, it remains hidden, a subtle force that refuses to reveal itself. It is both a presence and a Pazula paradox that stretches across the very fabric of space. Scientists have known of its existence for decades, but understanding it remains an elusive goal. Imagine you are standing in a vast, empty room. The walls stretch out before you, but you cannot see them. Yet you can feel their presence. You sense the way the air around you moves, the subtle pull of the room itself. You know, without seeing, that the walls are there, shaping the space around you. Dark matter is like these unseen walls, felt but not seen. We know it's there, and we feel its influence, but we cannot directly observe it. The idea of dark matter was first whispered to the scientific community by a man named Fritz Zwicky in the 1930s. He was studying the Coma Cluster, a collection of galaxies bound together by an invisible force. Zwicky noticed something strange. These galaxies were moving too fast for the amount of visible matter within them. According to the laws of physics, they should have been flying apart, their velocity too great for the gravitational pull of the visible matter to hold them together. Yet they remained bound, their motions steady. There had to be something else at play. Zwicky, observing this anomaly, postulated the existence of a mysterious substance that could be exerting a gravitational pull on the galaxies. He named it Dunkel Materie, or dark matter. However, Zwicky's idea was not immediately accepted by the scientific community. At the time, the concept of an invisible, undetectable substance seemed far too speculative. Without concrete evidence, many dismissed it as an unprovable hypothesis, a wild guess that lacked the weight of real science. For decades, dark matter remained little more than a speculative idea, a whisper that scientists couldn't fully grasp. Yet, Zwicky's hypothesis was a seed, and slowly, over the years, more evidence began to surface, building the foundation for what would eventually become one of the most significant discoveries in modern science. You feel the pull of curiosity. As we move forward, gently, into the 1970s, another astronomer, Vera Rubin, was studying the rotation of galaxies. She observed something that would change everything. Stars on the outer edges of galaxies were moving much faster than expected. The laws of physics dictated that the farther stars were from the center of a galaxy, the slower they should move. But Rubin found that these stars were moving at the same speed, even at great distances from the galaxy's center. This was puzzling. If only visible matter existed, These stars should have been flung out of their galaxies, their speeds too great to remain tethered. Yet they stayed firmly in place. It was as if something unseen and mysterious was holding them there. Rubin's observations suggested that, like Zwicky had proposed decades earlier, there was more to the universe than met the eye. Dark matter, invisible yet undeniably real, was pulling on the stars, keeping them within the gravitational grip of their galaxies. And just like that, a puzzle that had once been dismissed, dark matter, the unseen force that quietly held galaxies together, was no longer just a speculative idea, was a cornerstone of modern astrophysics. You can picture the vastness of it all. The galaxies swirling in the darkness, their stars, bound together by this invisible presence. The universe, filled with light and energy, is also filled with shadows. Dark matter is like a shadow, casting its influence across the cosmos. Unseen but ever present, this mystery, dark matter, is still with us today. We continue to search for answers, to unravel its secrets, and though we cannot see it, we can feel its effects. Its presence is evident in the way galaxies form, in the way the universe bends and stretches under its silent influence. It is the quiet architect of the cosmos, shaping everything we know, yet remaining forever out of sight. As you settle deeper into the rhythm of the universe, imagine yourself floating in this vast, dark ocean. Dark matter surrounds you like the gentle pull of an invisible current. You cannot see it, but you can sense it guiding, shaping, and creating the cosmos. Just as we cannot see the wind, but we feel it on our skin, dark matter is a quiet force in the universe, always there, always shaping, and yet always just beyond our reach. And so, the mystery continues. With every new discovery, we inch closer to understanding this elusive force. But for now, as you rest in the silence of the cosmos, remember that dark matter is the gentle pull that keeps everything in balance. It is a whisper in the void, a presence felt but unseen, waiting for us to uncover its secrets. And in that quiet mystery, the universe reveals its beauty, a place where even the unseen can shape the destiny of everything. As you settle deeper into the stillness, imagine the universe as a grand canvas, endless, stretching, and alive with subtle motions. Every star, every galaxy, and every cosmic cluster seems to move and dance. But who is the unseen hand that guides this magnificent ballet? There is, in the vastness of it all, a force so gentle, so quiet, it goes unnoticed by most dark matter. In the invisible, mysterious depths of space, dark matter is the unseen architect, the force that shapes the universe's very structure. Just as an architect designs the invisible framework of a building, dark matter exerts a quiet but essential influence, creating the very scaffolding of the cosmos. Without dark matter, galaxies would not hold together, stars would not form as they do, and the universe itself would be an entirely different place. Yet, in all of its work, dark matter remains a shadow, ever present, but forever unseen. You may think of dark matter as the cosmic thread that binds everything together, like the strings of a grand marionette, holding the stars and galaxies in place. But what exactly is this force, and why does it remain so elusive? To understand this silent architecture, we must first take a step back into the early days of the universe. When dark matter began its work, in the beginning, The universe was born in a fiery explosion, the Big Bang. This event, like a vast cosmic wind, scattered particles across the vast, empty expanse of space. In the chaos of the early universe, matter was in a state of constant motion. Stars, gas, and dust were flung outward, and yet, as the universe expanded, dark matter began to play its part. Dark matter's role in the early universe was subtle but powerful. Just as a gentle breeze shapes the surface of a river, dark matter influenced the formation of the first galaxies. Its gravitational pull, though unseen, was strong enough to pull together matter that would eventually coalesce into stars and galaxies. It provided the invisible scaffolding upon which the visible universe would eventually be built. The formation of galaxies, however, is not an easy task. It is a slow, careful process, one that takes place over billions of years. Imagine a seed being planted in the soil, its roots spreading deep into the earth. The seed doesn't grow overnight, but it slowly, gradually takes shape, guided by invisible forces beneath the surface. In much the same way, galaxies are born from the invisible influence of dark matter. Dark matter gathers together the stars and gas, pulling them toward the center of galaxies. Without dark matter's guiding hand, galaxies would not form as we see them today. They would spin out of control, with stars scattered in every direction, never able to come together to form the beautiful spirals, ellipticals, and irregular shapes that we observe in the night sky. Dark matter's gentle touch holds everything in place, keeping stars, planets, and cosmic dust bound together by its invisible force. But how do we know that dark matter is the architect of the universe? This question brings us back to the cosmic dance of galaxies. When we look at a galaxy, we see the stars, the dust, and the gas all swirling together in a vast, graceful rotation. But what we cannot see is the dark matter that is holding it all together. We know dark matter must be present because the galaxy's motion tells us so. The stars on the outer edges of the galaxy should, by all accounts, be flung out into space, their speeds too great to remain within the galaxy, yet they stay in orbit. Something is holding them in place. It is here, in the gentle rotation of galaxies, that dark matter reveals itself. Its invisible grip on galaxies is the silent force that ensures they stay together. Without dark matter's influence, galaxies would not be able to hold their shape, and the universe would be a very different place, one without the graceful spirals of the Milky Way or the elliptical clusters of stars that we know today. As you float gently through the cosmic sea, you begin to understand that dark matter's role is not merely passive. It is not just a bystander in the universe's grand drama, it is an active participant. It is the unseen architect, the quiet force that has shaped the very structure of the cosmos. Without it, the universe would not be as we know it. It would lack the elegance and beauty of galaxies spinning through the endless void. And yet, despite dark matter's monumental importance, we still know so little about it. We can't see it, we can't touch it, and we can't directly measure it. We can only infer its presence by observing how it affects the things we can see. But perhaps, in this mystery, there is a lesson. Sometimes, the most important forces in life are the ones we cannot see, but only feel. Dark matter is like the wind that moves the leaves unseen, yet undeniably present. As the universe continues its silent dance, galaxies continue to spin, their stars held together by the gentle, invisible hands of dark matter. The more we understand about the role of dark matter, the more we realize how interconnected everything truly is. From the smallest particles to the largest galaxies, every part of the universe relies on this unseen force, shaping the universe in ways we are only beginning to understand. You can imagine the universe as a vast, dark ocean, and dark matter is the current beneath the surface, guiding everything without ever making a sound. It moves with such subtlety that it seems to go unnoticed, yet its influence is everywhere. The stars, the galaxies, and even the very structure of the universe itself are shaped by this silent, invisible force. It is the great architect of the cosmos, working behind the scenes to create the beauty and complexity we observe in the universe. In this peaceful moment, you begin to feel a deeper sense of calm. The quiet architecture of the universe, the unseen forces at play, all work together in a delicate balance. You are a part of this vast, intricate design, shaped by forces both seen and unseen. And in this moment, you are reminded that even the smallest whisper can create ripples that shape the world around us. Much like dark matter shapes the universe. As you drift deeper into the cosmos, imagine the stars as dancers in a vast, timeless ballet. Their movements are graceful, flowing through the darkness, as if each one is following a carefully choreographed routine. And yet, despite their beauty, there is something deeper at play, a force that guides their motions, unseen, ever present. This force is dark matter, the invisible partner in their cosmic dance. The stars move in a delicate rhythm, their orbits shaped not only by the gravitational pull of visible matter, but also by the unseen hand of dark matter. Though we cannot see dark matter, we feel its effects in the way galaxies rotate, in the way stars trace their paths across the vast expanse of space. Just like a dancer moves with the rhythm of music, the stars move in harmony with the subtle gravitational influence of dark matter. Picture a galaxy spinning in space like a spiral of light, its stars tracing arcs in the cosmic void. As you watch, you notice something odd. The stars at the outer edges of the galaxy are moving at the same speed as those closer to the center. This shouldn't be happening. According to the laws of physics, stars on the outer edges should be moving slower as gravity weakens with distance. But they aren't. Instead, they seem to be held in place, their motions steady, synchronized. This is where dark matter enters the stage. The gravitational pull of the visible matter in a galaxy, its stars, gas, and dust shouldn't be enough to keep these distant stars from flying off into space, but they stay anchored in their orbits. It is as if there is an unseen force gently guiding them, pulling them back into the galaxy's gravitational embrace. Dark matter, though invisible, is the one holding everything together, ensuring that the stars do not drift away from their galaxy. As you drift further into this cosmic dance, you begin to understand that the stars are not moving randomly. Their paths are not a result of chance, but of a delicate interplay between the visible and the invisible. The visible matter, stars, gas, and dust interacts with dark matter, and together they create a perfect balance. Without dark matter, galaxies would not hold together, and the stars would not stay in their graceful orbits. It is dark matter that ensures everything moves in harmony, even though it remains hidden from our view. In the early 1970s, A scientist named Vera Rubin noticed this strange phenomenon in galaxies. She observed that stars on the outer edges of galaxies were moving too fast to be held together by the gravity of visible matter alone. This discovery marked a turning point in our understanding of the universe. It was no longer a matter of speculating about dark matter. It was becoming an essential part of the cosmic dance. It was a force that could not be seen, but its presence was undeniable, felt in the way galaxies spun and stars remained anchored in place. Imagine the stars as dancers spinning gracefully in the cosmic ballroom. They are guided by dark matter, their movements smooth and controlled, as if they are following the rhythm of an unseen conductor. Dark matter provides the framework that holds the galaxy together, giving the stars a place to dance. Without it, the dancers would scatter, lost in the vastness of space. You can picture the galaxies as a grand dance floor, where each star is a dancer, moving in perfect synchrony. The music of the universe plays softly, and dark matter is the silent conductor, guiding the dancers as they spin through the infinite void. There is no need for the stars to see their partner, for they feel the invisible hand that guides them, pulling them into perfect harmony with the rest of the cosmic dancers. In the vastness of the cosmos, this dance is eternal. Galaxies rotate, stars orbit, and dark matter, unseen yet ever present, ensures that everything stays in perfect balance. It is the force that holds the dancers in place, the thread that weaves the galaxy together. Just as a dance needs rhythm, the universe needs dark matter to ensure that everything moves in harmony, with grace and purpose. You might wonder, as you float through this cosmic ballet, why dark matter remains hidden from our eyes. Why is this force so essential to the structure of the universe invisible? It's as if it exists just beyond the reach of our senses, a mystery that we cannot yet fully comprehend. But perhaps this is part of the beauty of dark matter. Like a quiet partner in a dance, it does not seek the spotlight. It remains in the shadows, allowing the visible stars to shine, while still guiding their every move. As you float through this cosmic dance, you begin to realize that dark matter is not just a force that binds galaxies together, is the unseen rhythm of the universe, the quiet pulse that keeps everything in motion. It is the cosmic conductor guiding the stars, ensuring that the galaxies spin in perfect harmony. Without dark matter, the universe would be a chaotic, scattered place, with stars drifting aimlessly through the void. But dark matter's work is not done. As you drift deeper into this cosmic ballet, you begin to sense that there is more to the dance than meets the eye. The stars are not the only dancers on this vast stage. There are other forces at play, other hidden influences that shape the universe in ways we have yet to fully understand. Dark matter is just one part of the grand cosmic performance, but its role is essential. It is the silent architect of the universe's structure, the force that ensures the dance goes on. As the stars continue their motion, gracefully spinning through the cosmos, you are left with the quiet realization that dark matter is always there, guiding, shaping, and maintaining the rhythm of the universe. It is the unseen force that binds everything together, ensuring that the cosmic dance never stops. Imagine yourself standing at the edge of a vast, silent sea, where the only sound is the gentle whisper of the wind. The water stretches out before you, endless and deep. But there's a sense that something is waiting beneath the surface, something unseen, yet powerful. This is how the universe feels when we first encounter the enigma of dark matter. It is there, guiding the cosmos, but it remains hidden from our senses, just beyond the reach of understanding. In this quiet expanse, let's drift back to the 1930s, a time when the idea of dark matter was still a whisper, barely heard, and yet it was already shaping the universe. It was then that a Swiss astronomer named Fritz Zwicky first suggested the existence of dark matter. He was not looking at galaxies or distant stars, but at something much closer to home, the Coma cluster. A group of galaxies in our cosmic neighborhood, Zwicky had been studying this cluster of galaxies, and what he observed startled him. The galaxies, scattered across space, were moving much faster than they should have been, given the amount of visible matter in the cluster. According to the laws of physics, the galaxies should have been flying apart, their speeds too great for the gravitational pull of the visible matter to hold them together. And yet, they remained intact, their motions steady and synchronized. It was as though there was an invisible force, something unseen, holding the galaxies together. Zwicky, observing this strange phenomenon, proposed the idea that there must be an unknown substance exerting a gravitational pull on the galaxies. He called it dunkel materie, or dark matter. His insight was as quiet as the sea before a storm-an idea that would stir the world of astrophysics in the years to come. But Zwicky's idea was met with skepticism. How could something so invisible, so undetectable, have such a profound effect on the cosmos? At the time, there was no evidence to support his theory. Only the strange observations of the galaxies moving faster than they should. Dark matter, as a concept, seemed far too speculative, too intangible to be taken seriously. It was a whisper in the vast silence of the universe, and many believed it would remain just that, quiet idea, waiting for the right moment to be heard. But the universe, it seems, is full of surprises. While Zwicky's theory was met with doubt, it was also the beginning of a long journey that would eventually lead us to a deeper understanding of the universe and the forces that shape it. The idea of dark matter would continue to linger like the distant hum of a melody, waiting for the next note to be played. As time passed, more observations began to echo Zwicky's insight, though they would not be fully recognized until much later. The universe, it seemed, had its secrets, and dark matter was one of the greatest. Like a puzzle waiting to be solved, dark matter remained hidden, its presence felt only through its effects on the visible universe. The next major breakthrough in the search for dark matter would come in the 1970s, when astronomer Vera Rubin and her colleague Kent Ford were studying the rotation of galaxies. They had been examining the way galaxies spin, and what they found was nothing short of astonishing. The stars on the outer edges of galaxies were moving much faster than expected, so fast, in fact, that according to the laws of gravity, they should have been flung out into space. Yet, they remained in place, moving in perfect orbits, as if held by an unseen hand. It was a discovery that seemed to confirm what Zwicky had suggested decades earlier. Just like the galaxies in the Coma cluster, the galaxies Rubin and Ford were studying were moving in a way that couldn't be explained by visible matter alone. There had to be something else, something invisible, holding them together. Dark matter once a whisper, was now being recognized as a crucial part of the cosmic puzzle. As you float through the vast expanse of space, you can almost feel the weight of these early discoveries. Zwicky's insight, though initially met with skepticism, was like the first small ripple in a pond seemingly insignificant at first, but eventually growing into something much more profound. It was the beginning of our understanding of dark matter, a journey that would take us to the farthest reaches of the cosmos and beyond. Imagine the quiet persistence of Zwicky, standing at his telescope, peering into the depths of the universe, observing the strange motions of galaxies and sensing the presence of something invisible. It was as though he was hearing a distant song, its notes just out of reach. And yet, he had the insight to propose a theory that would eventually unlock the secrets of the cosmos. In this quiet moment, as you drift through the stars, you begin to appreciate the elegance of scientific discovery. It is not always a grand event, a sudden revelation. Sometimes it is a gentle whisper, a quiet idea that slowly begins to unfold, like the petals of a flower. Zwicky's insight was not the final answer, but it was the first step on a long and winding path toward understanding the unseen forces that shape the universe. As we journey through the cosmos, we are reminded that the universe is full of mysteries some we have yet to uncover, others waiting just beyond the edge of our understanding. Dark matter, though invisible, is one of the greatest of these mysteries. It is the quiet architect of the cosmos, the force that holds everything together, shaping galaxies and stars in ways we are only beginning to understand. And so, we continue the search. With each new discovery, we draw closer to the truth, inching, ever so slowly, toward understanding the silent force that has been shaping the universe since its very beginning. But for now, as you drift deeper into the night sky, remember that dark matter is not just a scientific mystery, it is a symbol of all the unseen forces that shape our world, waiting for us to uncover their secrets. Imagine you are floating gently through the endless reaches of the cosmos, suspended in a vast ocean of stars. There is no rush, no sense of urgency, just the quiet, slow pulse of the universe surrounding you. As you drift, you begin to notice something profound. All the stars, galaxies, and even the space between them seem to be connected, woven together by an invisible force, like threads in a grand cosmic tapestry. This is the fabric of the universe, and dark matter is its unseen weave. Though invisible to our senses, dark matter stretches across the cosmos, binding everything together with its subtle gravitational influence. It is the cosmic thread that runs through every galaxy, every star, and every planet, holding them in place within the vast, ever-expanding universe. To understand dark matter's role in this cosmic fabric, imagine a spider's web. The strands are fine and delicate, yet they are strong enough to hold the weight of the entire web. Each thread is connected to the others, and together they create a network that holds the structure intact. In much the same way, dark matter forms the invisible framework of the universe. It provides the gravitational foundation upon which galaxies, clusters, and even the space between them rely. Without dark matter, the universe would be an entirely different place. Galaxies would not be able to hold their shape, stars would drift apart, and the structure of the cosmos would be scattered like loose threads in the wind. Dark matter acts as the scaffolding, ensuring that everything stays in place, even as the universe continues to expand. It is the invisible force that keeps the cosmic fabric intact, guiding the formation of galaxies and ensuring that they remain bound together. But what is this fabric made of? What is the nature of dark matter, the unseen force that shapes the universe's structure? These are questions that have puzzled scientists for decades. And yet, despite our best efforts, the true nature of dark matter remains elusive. We can see its effects, how it influences the motion of galaxies, how it shapes the formation of cosmic structures, but we cannot see dark matter itself. It is like trying to understand the wind by feeling its effects, but never actually seeing it. In the grand cosmic scale, dark matter is like a force that runs through the very bones of the universe. It is what gives galaxies their form, what keeps stars from drifting apart, and what helps the universe hold its shape, just as the threads of a spider's web support the weight of the web itself. Dark matter supports the weight of the universe. It is the unseen hand that keeps everything in balance. When we look at the night sky, we see stars, planets, and distant galaxies, all shining brightly in the darkness. But behind the scenes, there is dark matter, working silently and steadily, holding everything in place. Its gravitational influence is felt everywhere, even though we cannot see it. It is the quiet, invisible force that makes the universe work as it does, providing the underlying structure that supports all visible matter. The idea of dark matter as a cosmic fabric may seem strange, but it helps us understand how dark matter functions in the universe. It is not just an invisible substance. It is the very structure that supports the visible universe, the framework upon which galaxies and stars are built. Without dark matter, the cosmos would not be able to form as it does. The stars would scatter, the galaxies would fly apart, and the universe would lose the intricate, beautiful structure that we observe today. Imagine the universe as a beautiful quilt, each piece of fabric woven together by dark matter. The stars, the galaxies, the space between them all are connected, part of a larger, intricate design. Dark matter is the thread that ties them together, the force that keeps everything in place. And just as a quilt is both delicate and strong, so too is dark matter. It is the quiet force that holds the universe together, unseen but essential. As you drift further into the cosmos, you begin to appreciate the vastness of this cosmic fabric. The galaxies spin through the void, their stars and planets held together by dark matter's invisible influence. It is a silent, graceful dance, one that has been unfolding for billions of years. Dark matter's role is both subtle and profound. It guides the formation of galaxies, clusters, and the very structure of the universe itself. You may wonder, as you float through this vast, silent universe, why dark matter remains invisible. Why can we not see it, touch it, or measure it directly? The answer is both simple and complex. Dark matter does not interact with light, and so it remains hidden from our senses. It is as though it exists just beyond the reach of our sight, a force that shapes everything yet remains elusive. But perhaps this is part of its beauty, the fact that it is both essential and invisible, like a quiet melody that plays in the background of a grand symphony. As you continue your journey through the stars, you begin to feel a sense of awe at the complexity of the universe. The more we understand about dark matter, the more we realize how interconnected everything truly is. From the smallest particles to the largest galaxies, every part of the universe relies on this unseen force, shaping the cosmos in ways we are only beginning to understand. Dark matter is not just a force, it is the very framework that makes the universe possible in the stillness of space. You can almost feel the pull of dark matter guiding the stars, shaping the galaxies, and weaving the fabric of the cosmos. It is the quiet architect of the universe, the force that ensures everything remains in balance. Without it, the universe would be a chaotic, scattered place. But with dark matter, everything is held together, like threads woven into a beautiful, intricate pattern. As you float through this cosmic tapestry, you are reminded that dark matter is not just a scientific mystery, is a symbol of the unseen forces that shape our world. Just as we cannot see the threads of a spider's web, but we know they are there, dark matter shapes the universe in ways we cannot fully see, but feel in the way galaxies spin and stars remain anchored in place. And so, as the universe continues to unfold before you, remember that dark matter is the quiet force that keeps it all together. It is the fabric of the cosmos, the invisible thread that weaves everything into place. Without it, the universe would be a scattered, disordered place. But with it, everything moves in harmony, held together by a force unseen but essential to the cosmic dance. As you float deeper into the cosmic sea, the stars around you begin to shimmer, their light soft and steady, each one a distant beacon, a flame burning in the vast, unending night. Yet, as beautiful as they are, you know that their light only tells part of the story. The stars, though radiant, hold secrets within them, secrets that are not immediately visible, hidden beneath the surface of their glowing exteriors. Just as a seed holds the potential for growth before it has sprouted, the stars hold mysteries beneath their shining facades. And among the deepest of these mysteries is the role of dark matter in their creation and existence. For it is dark matter that, though invisible to us, provides the gravitational scaffolding that allows stars to form, shine, and evolve over the course of their lives. The story begins in the early universe, where clouds of gas and dust drifted through the empty void. The universe, still young, was filled with this primordial matter, waiting for the invisible hand of dark matter to guide its transformation. It is through the gravitational influence of dark matter that the first galaxies and stars began to take shape. Without dark matter's influence, the matter that made up these stars would have remained scattered, unable to coalesce into the dense clouds necessary for stellar formation. Imagine a gentle breeze sweeping across the surface of a pond, causing ripples to form and spread. These ripples represent the gravitational effects of dark matter on the surrounding space, drawing matter together and causing it to condense into dense regions where stars can be born. Like the ripple of water, dark matter's pull is gentle, but its effects are profound. It shapes the universe, guiding the formation of stars, galaxies, and everything in between. Without dark matter, the stars we see today would never have formed. The clouds of gas and dust would have drifted aimlessly, never finding the gravitational pull necessary to collapse into the dense regions that create stars. It is dark matter's invisible grip that acts as the first architect of the stars, ensuring that the cosmic dance of creation begins. As you drift through space, you begin to see the intricate interplay between dark matter and the stars. The gravitational pull of dark matter helps guide the motion of the galaxies, but it also plays a crucial role in the birth of individual stars. Stars are not created in isolation. They are part of a much larger cosmic web woven together by the threads of dark matter. Each star is a small, glowing point in the grand, invisible structure that dark matter creates. But how, exactly, does dark matter influence the formation of stars? The answer lies in the subtle gravitational tug that dark matter exerts on the surrounding matter. In the early universe, dark matter formed clumps, or halos, which provided the gravitational force needed to pull matter together. As the gas and dust condensed, they began to form dense regions known as protostars. These protostars would eventually become the stars we see today, but only because dark matter helped shape their creation. The birth of a star is a delicate process, one that takes millions of years. It begins with the collapse of a cloud of gas and dust drawn together by gravity. As the matter compresses, it heats up, eventually reaching temperatures high enough for nuclear fusion to begin. And in that moment, a star is born, shining brightly in the darkness of space. Its light, a beacon of creation. But behind this process, dark matter's role is invisible. It is the silent force that guides the collapse of these gas clouds, ensuring that the conditions for stellar formation are just right. You might wonder how dark matter can influence stars if it doesn't interact with light or other forms of radiation. The answer lies in the fact that dark matter interacts with regular matter only through gravity. It doesn't need to emit light or absorb energy to have an effect on the universe. It only needs to exert a gravitational pull, and this pull is strong enough to shape the motion of galaxies and the formation of stars, guiding the creation of light in the darkness. As you float through this cosmic landscape, you realize that dark matter's influence on the stars is not just about creation, it is also about balance. Dark matter's gravitational pull helps prevent stars from becoming too scattered, ensuring that they remain bound within galaxies and clusters. Without dark matter, stars would not have the structure or stability they need to survive over long periods of time. They would burn out too quickly, their energies dissipating into the void. Dark matter, by guiding their formation and providing stability, allows stars to burn bright for billions of years, shining as beacons of light in the vastness of space. And so, the stars continue to shine, their light reflecting the invisible work of dark matter. They are born, live, and eventually die, but through each stage, dark matter plays a silent role. It shapes their formation, their motion, and their place in the universe. The stars are not solitary beings. They are part of a much larger cosmic web, woven together by the unseen force of dark matter. But even as we begin to understand the connection between dark matter and the stars, there are still many mysteries left to uncover. How does dark matter influence the creation of more complex structures, such as galaxies and galaxy clusters? What other secrets lie hidden within the stars, waiting to be discovered? As you drift deeper into space, you sense that the universe is full of such questions that we may never fully answer. But perhaps in the searching, we find the beauty of the cosmos itself. Dark matter, like a quiet presence, guides the stars, ensuring that they shine bright for eons. It is a force that works behind the scenes, shaping the universe in ways we can feel, but never fully see. And so, as you float through the stars, you are reminded that the mysteries of the universe are not always seen with the eyes. Sometimes they are felt with the heart, gentle, subtle, and ever-present. Dark matter is one such mystery, a force that shapes the stars and galaxies, a silent architect of the cosmos, guiding the universe's dance through the vast, unending night. As you drift deeper into the boundless reaches of the cosmos, the stars around you begin to form clusters, swirling gently through space. In the vast silence, there's a subtle sense of something at work, an invisible force that connects everything. It's not something you can see, but you can feel. It is soft, persistent pull that holds the stars and galaxies together, guiding their paths, shaping their movements. This pull is dark matter, an unseen force that silently influences the cosmos. You can think of dark matter's influence like the subtle tug of a current beneath the surface of a still lake. The water above remains calm and undisturbed, but underneath, the current moves steadily, shaping everything in its path. Dark matter is the cosmic current, unseen but profoundly felt. It works through gravity, a force so gentle yet so powerful that it holds entire galaxies together, keeping them from falling apart despite the tremendous speeds at which they move. You might wonder how something invisible can have such a strong pull. The answer lies in the nature of gravity itself. Gravity doesn't need light to work. It doesn't need to be seen or touched. It only needs to be present, and its effects are felt everywhere in the universe. Just like the pull of the moon on the Earth's oceans, dark matter exerts a gravitational force on the visible matter of the universe. It is this invisible pull that helps shape galaxies, stars, and all of the structure in the cosmos. Imagine a galaxy spinning slowly in the night, its stars tracing a delicate path around the center. The stars at the outer edges of the galaxy should be flying off into space, their speeds too great to remain bound by the galaxy's gravity. But they don't. Instead, they stay locked in their orbits, guided by an invisible force. This is dark matter at work. Its gravitational pull is strong enough to hold the galaxy together, even though it cannot be seen or measured directly. This unseen force is what keeps everything in place. Without dark matter, galaxies would be scattered, their stars flung out into the void. There would be no cosmic structure, no clusters or clusters of galaxies held together by invisible threads. But dark matter's gravitational pull prevents this from happening. It is the invisible force that holds the universe together, the thread that weaves the fabric of the cosmos. In the 1980s, astronomers studying the rotation of galaxies began to notice something curious. As they measured the movement of stars at the outer edges of galaxies, they realized that the galaxies were spinning much faster than expected. According to the laws of gravity, the stars at the edge should be moving much slower. The outer stars should have been flung off into space by their speed, yet they remained bound within the galaxy. This was a crucial observation, one that would eventually lead to the acceptance of dark matter's existence. It was as though the galaxies had an invisible anchor, a gravitational pull that prevented the stars from scattering into the vast expanse of space. That anchor was dark matter. It was the missing piece in the puzzle, the unseen force that explained the strange movements of galaxies. This discovery helped confirm what had been hypothesized decades earlier, the presence of dark matter, shaping the universe's structure without ever being seen. Dark matter's role doesn't stop with galaxies. It extends throughout the entire universe, exerting its gentle pull on galaxy clusters and large-scale cosmic structures. Just as individual galaxies are held together by dark matter, so too are galaxy clusters. The immense clusters of galaxies that we see in the sky would not exist in their current form without dark matter. It is the unseen glue that binds them together, allowing the universe to take shape in a way that seems impossible. If we only considered the visible matter, imagine the universe as a giant web, with each galaxy a thread, each star a delicate knot. Dark matter is the invisible hand that weaves this web, ensuring that the galaxies stay connected, that the universe remains stable. Without dark matter, the web would unravel, the galaxies would drift apart, and the universe would lose its form. But with dark matter, the web holds strong. It is the quiet force that keeps everything in balance, the invisible pull that ensures the universe stays intact. You might begin to wonder, as you drift through space, whether dark matter could be more than just a passive force. After all, if it can shape galaxies and influence the structure of the universe, doesn't that make it more than just a gravitational pull? Could dark matter hold other secrets, perhaps even be a clue to understanding the deeper mysteries of the cosmos? The answer to this question remains elusive, but the pursuit of it brings us closer to the unknown, to the hidden truths of the universe. For now, though, as you drift gently through the cosmic sea, you can sense the invisible pull of dark matter guiding everything in its orbit. It is a force so gentle, yet so profound, that it shapes the universe without ever being seen. Like the invisible wind that moves the trees, dark matter is always there, always pulling, always shaping, and always creating the cosmic order we observe. As the stars continue to move in their graceful dance, you realize that dark matter's influence is not just a cosmic force. It is a reminder that there is so much we don't yet understand. It is a force that is beyond our senses, but still, it shapes everything we know. In its quiet presence, it challenges us to look deeper, to explore the unseen, and to wonder about the mysteries of the universe that remain hidden from our view. And so, as you drift peacefully through the stars, remember that dark matter is not just an invisible force, it is the guiding hand that keeps everything in balance, the cosmic pull that ensures the universe continues to move in harmony. Though we cannot see it, we can feel its presence in the quiet motion of the stars and galaxies. It is the force that holds everything together, and in that stillness, we find the beauty of the cosmos. As you drift silently through the vastness of space, the stars twinkle softly around you, each one a distant flame flickering in the darkness. The calmness of the cosmos surrounds you. Yet, beneath this tranquil stillness, a revolution is quietly unfolding. A revolution that would forever change our understanding of the universe. It is a revolution that began with a question, a simple yet profound question that would guide scientists on a long journey toward the discovery of something unseen, something beyond our reach. That question was, what is dark matter? The story of this quiet revolution begins in the 1970s, with the careful work of an astronomer named Vera Rubin. Her task was to measure the rotation of galaxies. to observe the way stars move within them. Rubin's studies focused on a particularly puzzling phenomenon. The stars on the outer edges of galaxies were moving far too fast to be accounted for by the visible matter within the galaxies. The laws of gravity predicted that stars farther from the center should move more slowly, and that they should eventually be flung out of the galaxy due to their speed. But Rubin's measurements told a different story. The stars on the outskirts of galaxies were moving just as fast as the stars closer to the center. This unexpected observation was like a quiet whisper, urging her to look deeper, to search for something that might be hidden. At first, she didn't know what to make of it. How could the stars be moving in such a way? How could they be held in place without an adequate gravitational pull from the visible matter? The answer, as Rubin would soon discover, was dark matter, an invisible substance exerting its own gravitational influence, was keeping the stars bound to their galaxies, preventing them from flying apart. It was a revelation that would change everything. Rubin's work provided some of the strongest evidence yet for the existence of dark matter. For the first time, the idea that dark matter could be the missing piece in our understanding of the universe was becoming a widely accepted theory. And yet, even as this quiet revolution began to unfold, there was still much to be learned. Scientists had found the evidence, but they still didn't know what dark matter actually was. It was still a shadow in the night, a presence felt but never seen. As you float through this cosmic scene, you can almost feel the excitement of those early moments, when scientists realized they were on the verge of discovering something profound, something that would forever change the way we look at the universe. It was as though a veil had been lifted, revealing a hidden layer of reality that had always been there, just beyond the reach of our understanding. And yet, despite the evidence for dark matter's existence, it remained an enigma. No one could see it, touch it, or measure it directly. It was as if the universe had gifted us a puzzle, but didn't provide the pieces to solve it. How could something so essential to the structure of the cosmos remain invisible? How could it affect everything we see and feel in the universe, yet remain so elusive? These were the questions that haunted scientists as they worked to uncover the secrets of dark matter. This quiet revolution in astrophysics was not an overnight change. It was a gradual process, one that involved years of careful study, observations, and experiments. But as more evidence accumulated, it became clear that dark matter was real, and it was everywhere. It was the invisible scaffolding that held galaxies together, the cosmic glue that prevented the universe from falling into chaos. But even as dark matter was being accepted as a fundamental part of the universe, there was still much we didn't understand. What exactly was dark matter made of? What particles or forces could explain its behavior? Theories abounded, but there were no definitive answers. Some scientists speculated that dark matter was made up of weakly interacting massive particles, or WIMPs. Others thought it could be composed of exotic particles like ixions, or perhaps even neutrinos. And some proposed that dark matter might not be made of particles at all, but rather a form of energy that we couldn't yet detect. For now, the answers remained out of reach, like a distant star just beyond the horizon. But that didn't stop the search. Scientists around the world continued their quest to understand dark matter, conducting experiments, building new telescopes, and developing new theories. It was a search that spanned decades, and one that would continue into the future. As each discovery led to new questions, new mysteries to unravel, as you drift through the stars, you can't help but feel a sense of wonder at the beauty of this quiet revolution. It wasn't a sudden, dramatic event, but a slow, patient unfolding of discovery. It was like watching a flower bloom, petal by petal, as the world around it slowly came into focus. Dark matter, once a speculative idea, was becoming a cornerstone of our understanding of the universe. Perhaps, in this quiet revolution, there is a lesson for all of us. Sometimes, the most profound discoveries are not the ones that come with a flash of light or a sudden realization. Sometimes, the most important revelations are the ones that unfold gently, over time, like the soft unfolding of a flower. They are the discoveries that happen in the silence, in the stillness, when we are patient enough to listen and look closely enough to see. And so, as the universe continues its dance, dark matter remains at its heart, an invisible force that shapes everything we know. The quiet revolution that began with Vera Rubin's observations has led us to a deeper understanding of the cosmos. It has shown us that even the most elusive forces are vital to the structure of the universe, and that there is still so much more to discover, waiting just beyond the horizon. As you gently float further into the cosmos, you feel a sense of calm enveloping you, like the peaceful quiet of a forest at dusk. The stars around you glow softly, their light faintly reaching across the dark expanse. The universe stretches endlessly, and you realize that in this infinite space, there is something profound, something waiting to be discovered. Dark matter, a force so crucial to the structure of the universe, yet still so elusive, it remains hidden in the shadows. You can almost feel the quiet pulse of curiosity that drives humanity to seek the unknown. For decades, dark matter has remained a mystery, a presence whose effects we can feel, but whose nature we cannot fully comprehend. And so, scientists across the world, from laboratories deep underground to observatories high above the earth, have begun searching for this elusive force. Their search is not a frantic rush, but a steady, patient journey, a quest to uncover what lies in the darkness. Imagine yourself suspended in the quiet of space, watching as the scientists' instruments work silently, reaching out into the void. They are looking for traces of dark matter signals that might reveal its true nature. These instruments are as sensitive as your own heartbeat, tuned to detect the faintest whispers of dark matter's presence. In the vast silence of space, these delicate instruments are our ears, listening for the quiet hum of dark matter as it gently influences the universe. The first efforts to detect dark matter directly began in the 1980s, when scientists turned their attention to the very nature of dark matter itself. The leading theory at the time was that dark matter might consist of weakly interacting massive particles, or WIMPs. These particles, though incredibly small, would be able to interact with regular matter, but only through the weak nuclear force and gravity. This made them nearly impossible to detect, but not completely undetectable. If WIMPs existed, they would occasionally collide with regular matter, producing faint signals that could be measured, and so experiments began. Some scientists turned to detectors buried deep underground, away from the noise of cosmic rays and other interference. These detectors housed deep within the Earth's crust, were designed to catch the faintest interactions between WIMPs and the regular matter of the detector. These deep underground labs, hidden from the noise of the world above, were the perfect place to search for the elusive particles that might be dark matter. Here, the quiet of the Earth itself allowed scientists to listen more closely to the whispers of the universe. You can imagine, as you drift in the silence, that each of these experiments is like a tiny candle in the darkness, flickering softly, in search of a truth that has been hidden for so long. Each piece of data gathered, every tiny signal, brings the scientists a little closer to understanding the nature of dark matter. It is a search that is filled with anticipation, but also patience, as the scientists wait for the breakthrough that will finally shed light on the mysterious force that shapes the universe. As you imagine the instruments working below the Earth's surface, you can't help but feel a sense of awe at the quiet persistence of the search. These scientists are not rushing toward an answer, but moving steadily, methodically, toward a discovery that could change everything. They are searching for something they cannot see, something that may not even be made of the same material as the things we know. And yet, they continue to look, because they know that even the smallest clue could lead to a deeper understanding of the universe. But the search for dark matter is not limited to underground labs. The skies themselves are also a place of discovery. Telescopes, both on Earth and in space, are constantly scanning the universe for signs of dark matter. One method of detecting dark matter indirectly involves looking for the effects it has on visible matter. Dark matter doesn't emit light, but its gravitational influence can bend the path of light traveling through space. This phenomenon, known as gravitational lensing, allows scientists to see the effects of dark matter as it distorts the light from distant galaxies. Gravitational lensing is like the ripples on the surface of a pond when a stone is dropped into it. When light passes through a cluster of galaxies, dark matter's gravitational pull bends the light, creating a distorted image of the galaxies behind it. By studying these distortions, scientists can map out the distribution of dark matter in the universe. It's as though dark matter is leaving behind a trail of faint, invisible footprints, and the scientists are following these clues across the cosmos, one galaxy at a time. As you gently float through space, you begin to sense that the search for dark matter is not just about finding one answer. It is about understanding the universe as a whole, how it formed, how it works, and how everything within it is connected. Dark matter is the missing piece of a grand puzzle, and every experiment, every observation, is a step closer to revealing the whole picture. But even as scientists search for dark matter, there is a deeper question. What does the search for dark matter tell us about the universe itself? Dark matter is not just a force that shapes galaxies and stars. It is a force that shapes the very way we see the cosmos. It challenges our understanding of matter, of gravity, and of the nature of the universe. In searching for dark matter, scientists are also searching for answers to the most fundamental questions about reality itself. The journey is long, but the path is full of discoveries, each one bringing us closer to a deeper understanding of the universe's hidden forces. As you float through the vastness of space, you realize that the search for dark matter is not just about uncovering a single mystery. It is about uncovering the secrets of the universe, one step at a time, And in that pursuit we find the beauty of the cosmos, a place of endless discovery, where the unseen shapes the visible and the mystery continues to unfold. As you continue your gentle journey through the cosmos, you begin to notice a subtle shift in the way the universe feels around you. The stars seem to glow a little brighter, their light reaching farther into the dark expanse, as if they are beckoning you toward something hidden just beyond your reach. The universe is vast, and yet within its depths there is a quiet, stirring a search for the unknown. And as you move through the infinite, you begin to feel the quiet presence of the candidates that might explain dark matter's elusive nature. Imagine, for a moment, that you are standing in a dimly lit room surrounded by shadows. You can sense the outlines of shapes, but you cannot see them clearly. You feel the presence of something important, but the details remain obscured. In this room, the quiet candidates of dark matter linger, waiting to be discovered. Each of them is a possible answer, a key that might unlock the mysteries of the universe. But for now, they remain in the shadows, hidden from view, waiting for the right moment to step into the light. One of the leading candidates for dark matter is known as WIMPs, or weakly interacting massive particles. These particles, though incredibly small, are theorized to have mass, which gives them the gravitational pull necessary to influence the universe. WIMPs interact with regular matter only through the weak nuclear force and gravity, making them nearly impossible to detect. They pass through ordinary matter like a soft breeze, invisible to the senses. Yet their presence is felt in the way galaxies move and the way light bends in space. You can imagine WIMPs as whispers in the night, faint and elusive, moving through the universe without leaving a trace. They are the unseen particles that may be responsible for the gentle pull of dark matter, shaping the structure of galaxies and clusters. Yet, despite years of searching, scientists have yet to detect WIMPs directly. They remain a shadow in the cosmos, a quiet presence that continues to elude our instruments. But the search for dark matter doesn't stop with WIMPs. There are other candidates, each one a potential explanation for the invisible force that guides the universe. One of these is the axion, a hypothetical particle that could account for dark matter's gravitational effects. Axions are theorized to be incredibly light, with a mass so small it is almost imperceptible. They interact with regular matter in a way that would make them difficult to detect, but their subtle presence might be enough to explain the unseen pull that dark matter exerts on galaxies and stars. The axion, like the WIMP, is a candidate that has yet to be confirmed. But its quiet presence in the shadows suggests that dark matter may not be a single substance at all. Instead, it may be a collection of particles, each one contributing to the force that holds the universe together. These particles, while invisible, may be woven together in the cosmic fabric of space-time, each one playing a role in shaping the galaxies and stars. There is also another intriguing possibility: the sterile neutrino. Neutrinos are particles that are known to interact very weakly with regular matter. They are incredibly small and almost massless, but they travel through space at speeds close to the speed of light. A sterile neutrino, in contrast, would be a heavier version of the standard neutrino. one that could interact with dark matter and help explain the gravitational effects we observe. While sterile neutrinos are a promising candidate, they, too, remain elusive, slipping through our grasp like a wisp of smoke as you float through the vast expanse of space. You begin to understand that dark matter may not be a single force, but a collection of quiet candidates, each one playing its part in the cosmic dance. They are the invisible threads that weave through the fabric of the universe, shaping galaxies and stars without ever being seen. Each candidate is a piece of the puzzle, a clue that will eventually lead us to a deeper understanding of the universe's mysteries in the search for dark matter. Every candidate is like a star in the sky, each one shining faintly, waiting to be discovered. The universe is full of possibilities, and as scientists continue to look for these hidden particles, they move closer to a deeper truth. The quiet candidates of dark matter are not just scientific concepts. They are symbols of the unknown, waiting patiently for the moment when they will be revealed. As you drift through space, you feel a sense of calm, knowing that these particles, though hidden, are always there, shaping the universe in ways we cannot yet fully comprehend. They are the unseen architects of the cosmos, and their quiet presence is the force that guides the stars and galaxies, creating the structure of the universe. With each step, each discovery, we come closer to understanding dark matter, and perhaps, in time, we will uncover the secrets of these quiet candidates, and the mystery of the universe will be revealed piece by piece. Until then, as you float gently in the calm, dark expanse, remember that the universe is full of unseen forces, waiting patiently to be understood, waiting for the moment when the shadows will finally give way to the light. As you float further into the cosmos, the stars around you seem to pulse gently, as though they are breathing, each one a vital part of a greater rhythm. The universe stretches infinitely, a vast, ever-expanding canvas where galaxies, stars, and planets are woven together into a beautiful tapestry. But as you drift through this cosmic sea, you begin to realize that this intricate structure, this magnificent universe, is not just the result of visible matter. It is dark matter, an unseen force that has shaped and continues to shape the very growth of the universe. You might think of dark matter as the silent gardener of the cosmos, nurturing the seeds of galaxies and stars, guiding them as they grow, and ensuring they remain connected within the vast, expansive space. Just as a gardener plants seeds in the soil, dark matter plants the seeds of galaxies in the dark expanse of space, allowing them to grow and evolve over time. Without dark matter's gentle guidance, the universe would be a much different place, scattered and chaotic, lacking the structure that allows galaxies and stars to flourish in the early universe. Shortly after the Big Bang, the cosmos was a hot, dense soup of particles, radiation, and energy. It was a time of turbulence, where everything was in constant motion, and the universe was still in its infancy. But even in this chaotic state, dark matter played a crucial role. It began to form clumps, or halos, of matter, which would later serve as the gravitational framework for the formation of galaxies. Picture a gentle breeze stirring a field of seeds, pushing them together into clusters. The seeds are still scattered, but they begin to gather, drawn together by the invisible hand of the wind. In much the same way, dark matter's gravitational influence began to pull together the particles of the early universe, forming the first structures that would eventually evolve into galaxies. These dark matter halos acted as the scaffolding that allowed matter to accumulate, providing the foundation for the formation of stars, planets, and everything else that we see in the universe. Today, as the universe continued to expand and cool, the gravitational influence of dark matter grew stronger. It created the perfect environment for the formation of galaxies. The gas and dust that filled space were pulled together by dark matter, coalescing into dense regions where the first stars would eventually form. This process took millions of years, but it was dark matter's invisible hand that ensured the galaxies formed in the way we see them now: beautiful, spiraling islands of stars, their structure carefully shaped by dark matter's influence. In a way, dark matter is the architect of the universe's structure, the force that guides the growth of galaxies and clusters. Without it, the universe would be a scattered collection of matter, with no organization, no patterns. Dark matter provides the gravitational framework that holds galaxies together, preventing them from falling apart despite the tremendous speeds at which they rotate. It is the unseen force that keeps everything in place, ensuring that galaxies, stars, and planets remain connected, forming the beautiful cosmic web that stretches across the universe. Imagine a giant web where each thread represents a galaxy, each not a star, and dark matter as the invisible thread that ties it all together. The galaxies move through space like the points of a cosmic dance, spinning and swirling in harmony, and dark matter is the force that keeps the dance going, ensuring that the galaxies remain bound to each other, their stars moving in delicate orbits. As you drift through the vastness of space, you begin to see how everything is connected, how each galaxy is part of a larger structure, woven together by the invisible threads of dark matter. You feel a deep sense of awe, knowing that dark matter is the silent architect of the universe's growth. It is the force that allows galaxies to form, to evolve, and to thrive in the vast expanse of space. The growth of the universe is not a chaotic process. It is a slow, deliberate dance, one that takes billions of years, and dark matter is the quiet force that guides every step, ensuring that the cosmic dance remains in perfect balance. It is the force that shapes the universe's growth, creating the galaxies, stars, and planets that fill the night sky. But even as we begin to understand the role of dark matter in the growth of the universe, there is still much we do not know. What exactly is the relationship between dark matter and the other forces in the universe? How does it influence the formation of more complex structures, like galaxy clusters and superclusters? These questions remain unanswered, like distant stars just out of reach, waiting to be explored. As you drift deeper into the cosmos, you sense that the universe is full of mysteries that are waiting to be uncovered, secrets that dark matter still holds. Each new discovery brings us closer to understanding the true nature of the cosmos. But there is always more to learn, always more to explore. Dark matter, though elusive, is the key to unlocking these secrets, the force that connects everything, shaping the growth of the universe and ensuring its continued evolution. And so, as you float gently through the stars, you are reminded that the universe is not a random collection of matter. It is a carefully crafted structure, shaped and guided by dark matter, the silent force that has been at work since the beginning of time. It is dark matter that has allowed galaxies to form, that has guided their growth, and that continues to shape the cosmos in ways we are only beginning to understand. In the quiet expanse of space, you can feel the presence of dark matter, like the steady pulse of a heartbeat. It is always there, gently guiding the universe's growth, shaping the galaxies and stars with its invisible hand. And as the universe continues to expand, so too does the mystery of dark matter, waiting for us to uncover its secrets, one discovery at a time. As you drift silently through the cosmos, the stars twinkling faintly in the distance, you feel a quiet, almost imperceptible pull. It is the pull of curiosity, the soft tug of discovery that guides humanity toward the unseen mysteries of the universe. For decades, dark matter has remained just beyond our grasp, an invisible force shaping the cosmos, yet always hidden from our senses. But now, as you journey further into the unknown, you sense the quiet hum of humanity's search, an ongoing quest to uncover the secrets of dark matter, to reveal its presence, and to understand its role in the grand design of the universe. The search for dark matter is not an easy one. Its invisible nature makes it incredibly difficult to detect. And yet, scientists have devised clever methods to search for the faintest traces of this elusive force. One such effort is the Lux-Eplin experiment, a cutting-edge collaboration designed to detect dark matter directly. Lux-Eplin, an acronym that stands for Large Underground Xenon Lux and Zonations of Electrons and Neutrinos, is a massive experiment, buried deep beneath the Earth's surface, where the noise of cosmic rays and other interference is minimized. It is in this deep, quiet place that scientists hope to hear the faintest signals of dark matter's presence. Picture yourself standing in the heart of a vast underground laboratory, surrounded by walls of rock and metal. The air is cool, and the silence is profound. Above you, the world moves unaware, but here, in this deep cavern beneath the surface, the search for dark matter is underway. The Lux-Eplin detector is housed in this quiet space, carefully shielded from the interference of the world above. It is a delicate instrument, designed to detect the rare interactions between dark matter particles and ordinary matter. Dark matter is theorized to be composed of particles that interact weakly with ordinary matter. These particles, known as WIMPs, or weakly interacting massive particles, are thought to pass through matter almost unnoticed, leaving only the faintest trace of their presence. The Lux-Eplin experiment uses liquid xenon as its detection medium, chosen for its ability to capture the rare signals that might be caused by dark matter collisions. The xenon is cooled to incredibly low temperatures, creating a perfect environment for detecting the tiny, fleeting signals that would indicate the presence of dark matter. In the depths of this underground lab, the detector is constantly searching, listening for the slightest disturbances. The scientists who work here are patient, knowing that dark matter is elusive, and that each experiment might bring them one step closer to understanding this mysterious force. The technology that powers the Lux-Eplin experiment is among the most advanced in the world, and yet the quest remains a quiet one, marked by long periods of anticipation and calm. Imagine the detector as a sensitive ear, listening intently for the faintest whispers of dark matter. The xenon atoms within the detector are prepared to respond to the slightest disturbance. When a dark matter particle interacts with the xenon atoms, it causes a tiny flash of light and a brief release of energy, which the detector can measure. These interactions are incredibly rare, but if dark matter exists, this is the way it will reveal itself to us, through these subtle, nearly imperceptible disturbances in the fabric of matter. As you float through the quiet vastness of space, you begin to appreciate the elegance of this search. It is not a race, but a patient, methodical journey. Each day, each experiment brings the scientists one step closer to the truth. The detector listens, the scientists observe, and the universe remains silent, waiting for the faintest signal that will change everything. The Luxaceplin experiment is not just about the search for dark matter. It is about the quiet perseverance of science, the steady determination to uncover the mysteries of the cosmos, no matter how elusive they may be. Even though no direct detection of dark matter has been made yet, the experiment provides invaluable clues. With each passing day, it refines our understanding of the possible properties of dark matter. By ruling out certain possibilities, it brings scientists closer to a final breakthrough. The experiment is a stepping stone, an essential part of a much larger journey toward understanding the universe. But the search is not limited to Luxaceplin alone. There are other experiments, other methods, all working together to reveal the presence of dark matter. From underground laboratories to space-based telescopes, humanity's search for dark matter is a global effort, one that transcends borders and brings together the brightest minds from all corners of the world. Together, these efforts represent our collective desire to understand the universe on a deeper level, to see beyond the visible and into the hidden forces that shape everything we know. As you drift through this cosmic journey, you feel a sense of connection to the scientists, to the quiet experiments unfolding beneath the Earth's surface. They are part of a larger story, a story that has been unfolding since the dawn of time. The search for dark matter is not just a scientific pursuit. It is part of humanity's quest to understand the universe itself, to uncover the hidden truths that lie beneath the surface of what we see in the quiet depths of the Luxaceplin experiment. You can almost hear the soft whisper of discovery, like the faintest ripple across a still pond. The universe is speaking to us, and dark matter is the message it carries, waiting for the right moment to be heard as the experiment continues. As the search for dark matter presses on, you realize that the quest is more than just about answers. It is about the journey itself, the patient, persistent pursuit of truth, the quiet determination to uncover the mysteries of the cosmos. And though we may not yet have the final answer, each step forward brings us closer to understanding the invisible forces that shape the universe, like a puzzle slowly coming into focus, one piece at a time. As you float softly through the boundless reaches of space, the stars around you shimmer gently, casting their quiet light across the dark expanse. In this vast cosmic ocean, where galaxies drift like silent islands, you feel a profound sense of stillness. Yet, beneath the tranquil surface, there is a hum, a whisper, signal waiting to be heard. It is a signal that might reveal the hidden presence of dark matter, the unseen force that has shaped the universe since its very beginning. you are not alone in this search. The scientists who study dark matter have spent years trying to catch these faint whispers, trying to listen for the gentle signals that might point to the existence of this mysterious substance. But dark matter does not reveal itself easily. Unlike ordinary matter, which interacts with light and other forms of radiation, dark matter interacts only through gravity and, possibly, the weak nuclear force. It passes through ordinary matter without leaving a trace, making it incredibly difficult to detect. Yet, scientists are patient. They know that even the faintest signal, a soft disturbance in the fabric of space-time, could lead them to the answers they seek. Imagine dark matter as a whisper carried on the cosmic wind. Its presence is felt, but it is never seen. The search for its gentle signals is like trying to listen for the faintest sound in a vast, silent room. Scientists have developed sophisticated instruments to detect these signals, hoping that one day they will catch the faintest trace of dark matter as it interacts with ordinary matter. One of the most promising methods of detecting dark matter involves looking for the faint, indirect signals it might produce when it interacts with other particles. When dark matter particles collide with ordinary matter, they might release a burst of energy, creating tiny flashes of light or other particles. These interactions are incredibly rare, but they are the clues that scientists are searching for. Just as a delicate bird's song might be heard only in the stillness of the forest, the faintest flashes of energy could reveal the hidden presence of dark matter. One such method of detecting dark matter is the search for gamma rays. When dark matter particles collide with each other, they may annihilate, producing high-energy photons, or gamma rays, as a result. These gamma rays travel across the universe, carrying with them the potential to reveal dark matter's secrets. Telescopes like the Fermi Gamma Ray Space Telescope are designed to scan the cosmos for these faint, distant signals, hoping to catch a glimpse of the invisible force that shapes the universe. Yet, even as we search for these gentle signals, we must remain patient. The universe moves at its own pace, and dark matter's whispers are soft, elusive, and fleeting. It may take years, even decades, before we detect the first definitive sign of dark matter's presence. But each signal, no matter how faint, brings us one step closer to understanding the universe on a deeper level. As you drift through the cosmos, you begin to appreciate the delicate nature of this search. It is not a loud pursuit filled with dramatic moments of discovery. It is quiet, patient, and persistent, like a soft breeze moving through the trees, barely noticeable yet essential to the world around us. Every experiment, every observation is another small step forward, another quiet whisper that brings us closer to the truth. One of the most fascinating aspects of the search for dark matter is that it is not just about finding one answer. It is about exploring the unknown, about listening for the signals that may reveal a hidden layer of reality. The universe is full of mysteries, and dark matter is one of the greatest. As scientists continue their search, they are uncovering not just the nature of dark matter, but the very nature of the cosmos itself. You might wonder, as you float through this silent expanse, whether the search for dark matter will ever come to an end. Will we ever truly uncover its secrets? Will we ever understand the forces that guide the galaxies, the stars, and the very fabric of space-time? The answer is uncertain, and perhaps it is meant to be. The universe, in its vastness, is full of mysteries that will never be fully explained. Yet, it is in the search for these answers that we find our deepest connection to the cosmos. It is through our curiosity, our willingness to listen to the faintest signals, that we come to understand the universe in new and profound ways. As you drift deeper into space, you realize that dark matter's whispers are not just a scientific pursuit. They are a reminder of the vastness and complexity of the universe, a force that has shaped the cosmos since its beginning, yet remains just out of reach. In the search for dark matter, we find the beauty of the unknown, the quiet hum of curiosity that drives us to understand the mysteries of the universe. And so, as you rest in the stillness of space, you are reminded that the universe is full of gentle signals, faint whispers that beckon us forward. Dark matter, though invisible and elusive, is one of these signals, a mystery that continues to unfold. Its presence is felt in the way galaxies spin, in the way stars move, and in the way the universe itself continues to expand. And as the search for dark matter continues, we are reminded that the universe is full of secrets that are waiting for us to uncover, one gentle signal at a time. As you drift further into the cosmic sea, the stars above you seem to pulse with a quiet rhythm, their light soft and steady, like the heartbeat of the universe itself. There is a gentle energy in the air, a calm anticipation. For though the universe is vast and filled with wonders, there is one mystery that still eludes dark matter. And as you float, suspended in the silence of space, you begin to realize that the answers we seek are not always straightforward. Theories about dark matter swirl through the minds of scientists, each one offering a glimpse into the unseen, like shadows on the wall of an ancient cave. Theories are like dreams unseen, yet powerful. They are the thoughts that guide us forward, the quiet musings that offer us a path toward understanding. And just as a dream can reveal hidden truths, the theories about dark matter are our way of reaching into the darkness, trying to grasp what lies just beyond the edge of our knowledge. One of the leading theories about dark matter is the idea that it is composed of WIMPs, weakly interacting massive particles. WIMPs are thought to be a type of particle that has mass, but interacts with regular matter only through the weak nuclear force and gravity. These particles are incredibly small, passing through matter almost unnoticed. The name WIMP reflects their elusive nature. Their weak interactions make them difficult to detect, but their mass allows them to have a gravitational influence on the galaxies, holding them together despite their rapid rotations. Imagine these WIMPs as faint whispers in the dark, moving through the cosmos without leaving a trace. They are the unseen particles that make up dark matter, passing through the fabric of space without interacting with light, leaving only their gravitational pull to mark their presence. These particles are theorized to be the source of the invisible hand that guides galaxies and stars, shaping the structure of the universe without ever being seen. It is this invisible influence that makes dark matter so difficult to detect. Its presence is felt only through the way it affects the visible universe. But even as WIMPs remain a leading candidate, they are not the only theory. There are others that offer different explanations for the strange gravitational effects we observe. One such theory involves the possibility of Ixion's extremely light particles that could also make up dark matter. Ixions are theorized to have no charge and an incredibly small mass, making them even more elusive than WIMPs. These particles could be abundant in the universe, filling the space between stars and galaxies, yet interacting so weakly with regular matter that we cannot detect them directly. The Ixion theory offers a new avenue for exploration, a path that could lead us to uncover the true nature of dark matter. As you float in the quiet vastness, you begin to feel the weight of these theories, each one offering a different way of understanding the unseen forces that shape the universe. They are like different strands of a cosmic melody, each contributing to the larger symphony of understanding. The theories about dark matter are not just scientific ideas, they are the whispers of the universe itself, offering us a glimpse into its hidden depths. And though these theories are still unproven, they guide the search for answers, like stars shining in the distance, each one offering its own light, are similar to the neutrinos we already know about, but with a mass and properties that could make them responsible for the gravitational effects we observe. Sterile neutrinos would be a special type of neutrino, one that doesn't interact with regular matter in the way that ordinary neutrinos do. Instead, they would interact with dark matter, helping to explain the gravitational effects we see in galaxy clusters and superclusters. This theory, though intriguing, is still in its early stages, with much research yet to be done. In the quiet of space, these theories swirl together like cosmic dust, each one offering a different perspective on dark matter. Some scientists believe that dark matter could be made up of exotic particles that exist outside of our current understanding of physics. Others speculate that dark matter might not be made of particles at all, but could instead be a form of energy that we have yet to detect. Perhaps dark matter is not a substance, but a phenomenon, a manifestation of the underlying structure of the universe that we have not yet fully grasped. As you drift through this vast sea of possibilities, you begin to realize that the theories about dark matter are not just scientific concepts, they are reflections of our curiosity, our desire to understand the mysteries of the universe. Each theory is a step forward, a gentle push toward uncovering the unseen forces that shape everything we know. And even though we may not have all the answers, it is in the search itself that we find the true beauty of discovery. Theories, like whispers in the night, lead us closer to the truth. Each one offers a piece of the puzzle, a glimpse into the cosmic mystery that dark matter represents. As you continue your journey through space, you are reminded that the universe is full of unanswered questions, full of things we do not yet know. And dark matter, though invisible, is one of the greatest of these mysteries. Perhaps, in time, the true nature of dark matter will be revealed. Perhaps one of these theories will be proven correct, and we will uncover the secrets that have been hidden for so long. Until then, the search will continue, each theory a step along the way. And as you drift in the silence of space, you feel the quiet pull of curiosity and invisible force, like dark matter itself, guiding you toward the answers that lie just beyond your reach. As you glide effortlessly through the endless night of space, you feel a sense of peace wash over you. The stars twinkle softly, casting their gentle light across the vast expanse. There is no rush, no urgency, only the quiet hum of the cosmos. The the rhythm of the universe unfolding at its own pace. And in this stillness, you come to realize that the search for dark matter is not just about the answers we seek, it is also about the questions that remain, the mysteries yet to be uncovered. The future of dark matter research is as vast and mysterious as the cosmos itself. Dark matter is a force unlike any other, invisible and elusive, but its presence is felt in the way galaxies spin, in the way stars move through the heavens, and in the way the universe itself unfolds. It is the cosmic thread that ties everything together, shaping the very structure of the universe. Yet, even as we stand on the precipice of discovery, there is so much we do not know. The true nature of dark matter remains hidden, its secrets waiting to be unlocked. And so, the search continues. The future of dark matter research holds both promise and uncertainty. Theories abound, each one offering a potential answer, but none have yet been proven. WIMPs, ixions, sterile neutrinos, each of these particles could hold the key to understanding dark matter. Yet we are still searching for the faintest signals that might confirm their existence. Each experiment, each observation brings us closer to the truth. But the journey is far from over. One of the most promising avenues for future research is the study of gravitational waves. These ripples in spacetime, caused by the movement of massive objects like black holes and neutron stars, carry information about the universe's most violent events. But gravitational waves also carry the potential to reveal hidden truths about dark matter. By studying these waves, scientists hope to uncover clues about the nature of dark matter, perhaps detecting its presence in ways we have yet to imagine. As you float gently through the universe, you realize that the search for dark matter is not just about the particles we might discover. It is about the process itself, the patient, methodical journey toward understanding the universe. The future of dark matter research is a journey that will take us beyond the stars, to the farthest reaches of the cosmos, to the edge of our knowledge. And as we continue to search, we may uncover not just the secrets of dark matter, but the deeper truths of the universe itself. The tools we use to search for dark matter will evolve over time. New telescopes, more sensitive detectors, and more advanced methods of analysis will open up new frontiers of discovery. And as our understanding of the universe deepens, we may begin to see dark matter in ways we never thought possible. But the search will remain patient, for dark matter is not something to be rushed. It is a whisper in the night, a quiet presence that reveals itself slowly, piece by piece. But perhaps the most profound lesson of all is that the mystery of dark matter is not just a scientific puzzle, it is a reflection of the universe itself. The cosmos is filled with things we do not yet understand, forces and particles that remain hidden just beyond our reach. And dark matter is a symbol of that mystery, a force that shapes everything we know, yet remains just out of sight. As you continue to drift through the stars, you feel a deep sense of wonder at the vastness of it all. The universe is so full of mystery, so full of secrets waiting to be uncovered. Dark matter is just one piece of that puzzle, but it is a crucial one. It is the invisible force that holds the galaxies together, the thread that weaves the universe into a harmonious whole. And as the search for dark matter continues, we are reminded that the journey is just as important as the destination in the future. we will continue to search for the signals that will finally reveal dark matter's true nature. And with each new discovery, we will come closer to understanding the very fabric of the universe. But for now, as you float through the peaceful expanse of space, you realize that dark matter is more than just a scientific mystery. It is a part of the grand cosmic story, a story that is still being written. The universe is still unfolding, still revealing its secrets, and dark matter is a key part of that unfolding tale. The future of dark matter research is a future of discovery, a future where the hidden forces of the universe will be brought to light. And as you rest, gently suspended in the cosmos, you know that the journey to uncover these secrets will never truly end. The universe will always hold something new, something unexpected, just beyond our reach, waiting for us to discover it. And in that mystery, we find the beauty of the universe itself, a place where the unseen is just as important as the seen, and where every answer leads to even more questions. As you settle back into the stillness of the cosmic sea, gazing out at the stars, you are gently reminded that the journey through the mysteries of dark matter has been more than just a search for answers. It has been a quiet exploration, one that has led us deep into the heart of the universe itself. Along the way, we have uncovered whispers of invisible forces, the unseen threads that bind galaxies together, shaping the cosmos in ways that are still beyond our full understanding. Through each chapter, we have discovered that dark matter is not just a scientific concept. It is a symbol of the mystery and wonder that fill the universe. It is the quiet architect behind the scenes, influencing the motion of galaxies, the birth of stars, and the very structure of the cosmos. Its presence is felt everywhere, yet it remains hidden from our senses, leaving us with a profound sense of curiosity and awe. The search for dark matter continues, as humanity's quest for knowledge leads us to new discoveries, new questions, and new mysteries. But perhaps, in the end, it is not just about finding the answers. It is about embracing the unknown, about understanding that the universe is vast and filled with wonder, and that there is always more to learn, more to explore, and more to discover. As you float gently through this endless expanse, you sense the quiet presence of dark matter, a reminder that even the most elusive forces have the power to shape the universe. It is in the pursuit of understanding that we find the true beauty of the cosmos, not in the certainty of answers, but in the joy of discovery, in the quiet moments of wonder when the universe reveals just a little more of its secrets. And so, as the stars continue to shine in the infinite night, remember that the journey does not end here. The mysteries of dark matter, like the universe itself, are vast and ever-expanding, and there is always more to learn, more to uncover, in the silence of space, where the unseen shapes the visible. We are reminded that the universe is not a place of certainty, but one of infinite possibility.